Hello, everybody. Welcome to our session, Modernize Legacy Java Application with Anthos. I'm Harish Jayakumar. I lead the Application Modernization Solutions team. And today, along with me for this talk, I have Ameer.
Hello, everybody. My name is Ameer Abbas. I am a solutions architect out of San Francisco.
Thanks, Ameer. So, quick guidelines. All these slides that we'll be sharing today and all the information is Google confidential and proprietary. It's shared under NDA. So please be careful what you share and how you use them. With that, let's get started. So when we talk with customers and any C-level executives, they all have a digital initiative in the organization. But the problem with executing those initiatives is that there are a lot of legacy systems that hinder the business agility while consuming majority of the IT spend. And when we talk about this majority of IT spend, we talk about legacy applications like Java and .NET applications, which is based on very, very tightly coupled architectures and messy integrations. And these legacy systems therefore inhibit achieving any cost efficiencies across the board, across managing these legacy applications and new applications, maintaining security and compliance requirements, and ensuring quality of service to the customer and reliability of solutions, as well as it's also going to prevent them from the agility in shipping new features to their customers as well. So modernizing Java systems is a priority for many enterprise customers. So as you can see from the statistics over here, we've seen that more than 80% of companies are saying they're going to continue to leverage the past investments in Java applications. And 40% of the companies will modify these legacy Java apps for cloud migration. 79% will modernize Java apps with cloud-native technologies with containers and Kubernetes as well. So as you can see, Java clearly dominates when it comes to deploying application in production environments. And that's going to be the focus of the talk today. So, but what are the challenges in modernizing these legacy Java applications? First off, rewrite is not a viable option for many workloads. Yes, you might want to take and rewrite all these applications, but think about a company that has hundreds and thousands of legacy applications. It becomes really, really complicated. Sometimes these applications are so old that they don't even have access to the source code, or the developers who actually wrote those applications are no longer here. Second thing is, the question I get asked is, well, why can't we just lift and shift VMs? Sure, it's a safe bet, but there are a lot of those benefits from the new technologies that you're not going to be able to get. And there's also significant cost increase due to lack of density per host in VMs. And then finally, the thing that I tell the customers is that most importantly, we don't see app modernization as a binary problem. Even if you can't get all the benefits, customers are like, can I get some of the benefits? And that's what I talk about when we say meeting the customers where they are. Depending on your risk portfolio, depending on the application portfolio, we have choices to take them anywhere that they want. Which brings us to what is Google's point of view when it comes to modernization. It basically is the future of applications and the infrastructure that they run on is created with containerized microservices, managed through a declarative system. A declarative system is where code represents the final state. So Kubernetes is a perfect example. With a single control experience that uses a service mesh to span all the applicable locations. So service mesh, as you know, is a configurable low latency infrastructure that ensures communication among these containers applications. So now that you have these applications running as containers, you want to be ensuring that there's mutual TLS between them. You get all those components right out of the box using service mesh to span all applicable locations on there. And how do we take all of that we want to achieve with modernization? We put it into a solution which is called as Anthos. So Anthos is a managed application platform that's based on Kubernetes Istio Knative for enterprises that want faster modernization, right? And we talk about this, what I talk about when I say tools to perform no-touch migration and greater consistency in a hybrid and multi-cloud world. So when we talk with customers, quickly what happens is we first work with them in saying how we can help them see the business benefits that they're associated with, the same problem that we started off first. Here's an example of a Java landscape at a software company. As you can see over here, the estimated benefits over a 3-year period totally pays off. In fact, even in year one, after the investment in Anthos, you can see the licensing cost and support for Java workloads that they're getting in positive, as well as being able to refactor and migration cost due to modernization as well. 80% of them were due to refactoring of their Java legacy applications and their other apps as well. But how do we go about doing this? I call this a very simple 3-step process, right? Step 1 is we migrate the application as is. And this is where I'm going to say that it's a lift and modernize, not a lift and shift, because we're taking the application and we're converting them to containers. And the business benefit is immediately in that first step, you're able to see the 37% TCO savings right out of the box. Now that you have this as a container, you can actually connect it to an automated testing and deployment through a CI/CD process or whatever. And then at your leisure, you can refactor and replatform. And as a combination, you can see an extra 78% TCO savings. So let's start categorizing these apps. Not all apps are the same. So when it comes to Java application categories, we've actually categorized them into 4 buckets. First is the applications that are using modern frameworks. These are prime candidates for containerization. You must have heard of the term greenfield applications. So if your customers or you are using anything like web applications, RESTful APIs, Spring Boot, those are great candidates which we can quickly take and move them to containers using dev tools to containerize them that we have. Second, we have packaged applications. So these are commercial off-the-shelf components. Maybe you don't own the source code for these applications at all anymore. So you can take this as well, and you can actually use migrate for Anthos and move them to containers just like I talked about. And the third bucket is brownfield applications. To clarify, when I say brownfield applications, it's not a new application, it's not greenfield, but there is applications that's running, it's still generating revenue, and active code is being checked in and features are being checked in. These could be in your, again, monolithic legacy app servers, WebLogic, WebSphere. These are also great candidates for migrate for Anthos, or some of the GSI tools as another option as well, which I'll talk about a little bit before we move on to focusing on one of the options. And then finally is the legacy backend apps. It's totally cool. You don't need to take them and move all the application to containers. You're going to have some things that you just want to leave them either running them on your VMware or your virtualization environment, or you can use them connecting with Apigee. But with Anthos, you can still manage VMs as well. So as you take those 4 buckets, you can see that you've actually categorized them into these 4 separate paths on this. And that's why customers would like to, when we talk with them, is like this prescriptive approach, depending upon the type of application, and there's a prescriptive path. For the first case, if it's like just out of the new greenfield applications, easy to containerize them, connect them to a CI/CD, and then take them to run them on Anthos. The second one is if you're able to take them, like I said, COTS applications, or you don't have the source code, containerize with migrate for Anthos, again, run them on, and then pull them and run them on Anthos. And then the third one is any business critical applications, the brownfield applications we talked about. We could use our GSI tools or migrate for Anthos or migrate for VMs as well. And then finally, extreme legacy. But as you can see, all these lead to Anthos, where you can manage and maintain them, and then you can refactor and replatform them to microservices at your leisure. That same 3-step process that I talked about before with the savings. So from Google Cloud, we're recommending for those 4 buckets, 3 options for you to modernize these Java applications. Option 1, which will be the focus of this talk, we'll be going into detail, is basically how to lift and modernize these applications to containers using migrate for Anthos. Like I said, these are great candidates when you don't have access to source code. Option 2 is brownfield applications with proprietary framework. So for example, we've actually partnered with some GSI tools where we can help you take your code, we look at the code, strip out the commercial component, insert open source components, and generate a GitHub repo, which you can then connect to your CI/CD pipeline and get all the benefits that you want. And then finally is the refactor and replatform options. Out of Google Cloud, we have tons of frameworks and tons of tools to help you be able to refactor and rewrite them as containers with Spring Boot frameworks as well. But for today's talk, we're going to be just focusing on the migrate for Anthos solution. So migrate for Anthos allows you to move your VMs directly into containers right out of the box, right? Because it offers the customers a way to migrate the workloads, whether you're running them on VMs or bare metal. This provides a low friction path for any existing workloads quickly to move to Anthos and provides the accelerated migration as well and the modernization paths to additional cloud services. So what are good candidates to be able to migrate as well? So any web application server or business logic applications, middleware based, right out of the box, you can easily do that, take them and move them to using migrate for Anthos. From a workload perspective, low duty cycles and bursty workloads are great candidates as well. Some of them just use them for training or labs, but you can also run them in production as well. And then also like middleware frameworks that we talked about, Tomcat, WebSphere are great candidates for you to be able to use with migrate for Anthos. Basically, applications that are built on enterprise Linux are great candidates that you can quickly jump in wherever it's running on. Now that you've taken these applications, and this is where I talk about bridging the traditional and the modern one. You take these applications, you follow those 4 paths, and you run them on Anthos. Now you can start using the components that come with Anthos, which is Anthos Service Mesh, that can provide you provide a service management and a single pane of glass for managing your metrics, service identity, and traffic management purposes. And also Anthos config management as well, which is another piece that comes with Anthos that allows you to automate your policy and configuration at scale. So if you want to be able to synchronize your configuration across multiple clusters, whether it's on-prem or on the cloud, this allows you to make sure you do that, because it's also based off Git, so it enables auditability and review of CI through policy as code. So let's put all these things together, right? We talked about service mesh, we talked about configuration management and running these applications on GKE. So out of the box, you can take this, and that's what Anthos comes with. Migrate for Anthos, you're able to move these applications and run them and manage these independent of where you're running it below, whether it's going to be on Google Cloud, on-prem, or a hypervisor, AWS, wherever it is. So how does it work? Very quickly, we identify the workloads, whether it's running on VMs or on-prem, and then migrate for Anthos. Once we've identified the workloads, we take them and we auto-containerize them, and then now you've actually generated the CI/CD artifacts that you need. So basically, migrate for Anthos basically generates a Kubernetes YAML file and a Docker image and a Docker file, which you can then take and actually move them into Anthos or connect them to a CI/CD pipeline. And now once you're running it on Anthos, like I talked about, you can use all the service mesh and logging and capabilities as well. The key two important things over here to remember is it's not a lift and shift. You're not completely taking everything and simply just moving it into a Docker container. You can see the things in red: kernel drivers, management agent logs, things that do not matter. You're not actually taking them and moving them into the Docker, into the container world as well. And another key important thing, which is that it also handles persistent workloads. So as most of you know, for example, if you're running, say, your application on VMware and talking to say, vSAN, once you migrated it to Anthos, it actually converts them to persistent volume. So right out of the box, you're already in the Kubernetes ecosystem and how to be able to go use that. So it becomes easy for you to run on Anthos and get all the benefits like RBAC, autoscaling, everything right out of the box. So now that I've done the really, really hard work of clicking through slides, I'm going to hand over to Ameer to do the demo. Ameer?
Thank you, Harish. So in this demo, we are going to take a monolithic Java application running as a VM, use migrate for Anthos to convert that VM into a container, and then run that containerized application onto the Anthos platform. So here I am in my vCenter console, and you can see that I have a VM called java-app. Now this is a RHEL 7 app. Here's the IP address. And if we go to that IP address, you can see that it's backed by a WebLogic server. It's a single admin server. And we can also go to the front end. Now this is a sample app called Hipster Shop. It's kind of simulating an e-commerce experience. And you can see from the looks of it, it's looking fairly antiquated. And it's probably been stuck this way because it's quite painstaking to change anything in a monolithic application. So let's take this application as is, convert it into a container using migrate for Anthos, and then run that container onto the Anthos platform. And then over time, we also want to see how can the Anthos platform benefit this application as it gets refactored into microservices. So let's go into the GCP console. Here I am in my Kubernetes clusters page, and you can see that I have 3 Kubernetes clusters. I have a dev US West 2 cluster representing my dev environment, and a prod US West 2 cluster representing my production environment. We're going to take that containerized application and run it onto the dev cluster. We also have this third cluster called M4A processing. Now this is the migrate for Anthos processing cluster. Now it's running the migrate for Anthos controller that connects back to our VMware environment that I showed you, converts that VM into a container, and also generates all of the Kubernetes artifacts that are required to run that container into Kubernetes. All right, great. So let's jump into Cloud Shell. And first things first, let's make sure that we are connected to all of our clusters. So you can see that I'm connected to dev, prod, and M4A processing. And I'm actually going to run this demo a little bit backwards. I'm actually going to deploy the generated artifacts first, and then we're going to go back in time, and then I'll show you how we got to those generated artifacts. And the reason is because it takes 3 to 4 minutes to get that application up and running, and I don't want to waste anybody's time here. So for me to deploy it, I'm going to create a brand new namespace into the dev cluster. So let's call it Hipster Legacy CRM AA. And then I'm going to deploy the generated artifacts, which are inside of a file called deployment spec YAML inside of the Hipster Legacy CRM AA namespace. Okay, great. So a bunch of things got deployed. We'll take a look at those later. So now let's connect to our migrate for Anthos processing cluster. Now, as part of migrate for Anthos, we have a tool called MigCTL. that allows us to do a bunch of things. So first things, I want to see which sources am I connected to. Now, in addition to VMware, we can also connect to GCE instances or AWS EC2 instances. In this case, I'm just connected to my single VMware instance. Now, migration plans are stored as YAML files. And if we look at the list of files in this folder, you can see that I have a file called hipster CRM migration demo YAML. And if we inspect that file, this is the migration plan. It looks a lot like a Kubernetes YAML file. And you can see a few things. For example, I'm migrating both the image and the data. Remember, it's a WebLogic server. Here's my VM ID, java-app. If we scroll further down, you can see exclude filters. These are the folders I do not want migrated as part of my containerized app. So things like swap files or boot folders or temp folder. Right below that is my image information. The containerized image gets stored into a GCR registry, and here's the name of that image. Right below that is information about data. So here's the persistent volume claim that it's going to store that data in, and here's the folder inside of the VM, the DB folder, that it's going to convert that data from. Right below that is the bucket where the generated artifacts are going to get stored. And here's the name of the bucket where we're going to store that. And then right at the end, we have the application name that it's going to run in Kubernetes as, which is hipster legacy CRM. Okay, great. So let's go ahead and generate this plan. So I'm going to, again, use the migctl command, migration generate artifacts, and I'm going to run that plan. Now at this point, it's connecting back to my VMware environment, containerizing that application, and then generating all of the Kubernetes resources. And then those resources are stored into that GCS bucket. So now that it's done, let's look at that GCS bucket and see what got generated. So you can see that we have the Docker file, and then we also have that deployment spec YAML. Now this was the YAML file that I deployed at the very beginning of the demo. So let's go ahead and inspect that deployment spec. And if you're familiar with Kubernetes, this is a plain old vanilla Kubernetes YAML. So since this is a stateful application, it's created a stateful set. It can also create deployments if this was not a stateful app. It's also created a service with a service type load balancer. So it's going to expose this service with an external load balancer on port 7001. And then right below that, it's created a persistent volume claim for the data. And then lastly, it's also created a persistent volume with a GCE persistent disk. That's where all the data is going to get stored. So those were the 4 resources that it got deployed onto the dev cluster. So let's connect to the dev cluster. And let's change our namespace to the hipster legacy CRM AA namespace. And let's look at the pods inside of that namespace. Great, so you can see that we have this hipster legacy CRM stateful set with a single pod running. And remember, as part of that, we also created a service called hipster legacy CRM. And it's exposed with an external IP address. And it's exposed on port 7001. So if we take that IP address, and if we go to the front end of that IP address, which happens to be at this URL, you can see that it's looking exactly the same. The only difference is now this application is running as a containerized application on Kubernetes in the Anthos platform versus a virtual machine in VMware. So very easily, we were able to use migrate for Anthos, not do any kind of recoding or rewriting, and convert this application into a container, and then generate the artifacts that are needed to run this onto Kubernetes. Now, over time, we have refactored this application into a set of microservices and run this on the production cluster. So here I am in my workloads page, and I'm filtering this page by the prod US West 2 cluster. And previously, what was known as the hipster shop has now been facelifted, and now it's called the online boutique shop. And you can see that it's got a number of microservices like add, cart, checkout, currency, and so on. And if we go to the services page for that application, you can see all of the services for every single microservice, as well as this front end that's exposed on a public IP address. So we can navigate to that IP address, and hopefully you can see the kind of the new and improved experience of what was previously known as the hipster shop, now known as the online boutique. That's an e-commerce experience I can perform. I can do some shopping here. I can buy some vintage typewriters. These are all different services like cart service, checkout service. I can place the order using the checkout service. All of those microservices are working together to give us this application experience. Now, part of Anthos is what we're trying to do is bring Google SRE best practices to our customers that are using the Anthos platform. So here, if I go to the Anthos service mesh page, we are powering this application by the service mesh. And right off the bat, we get a lot of observability and security posture information. So we get all of our services that are running. Note, we also get the legacy CRM application that we converted. We get the status, health status of those applications. So some applications are healthy, some are not. We get the type of applications, which clusters they're running in, but also metrics like requests per second, error, and latency. We also get topology information for that application. So if we go into the topology page, you can actually see how requests are traversing. We can see the legacy one, which just has a simple load generator, just going straight into the legacy CRM app. But we also see the microservices-based online boutique app, which has the front end and is talking to a lot of different microservices. And if we hover over any of these microservices, we get additional information like queries per second and so on. We also get health status of each of these services right on the topology page. So recommendation service is healthy, but checkout service is not. So if we go to the checkout service, we can delve deeper into an individual service. So now I'm in the checkout service, and we can see what's going on with this service. So up top, we have a timeline of the health status of that service. And right now it's set to 1 hour time span. And you can see that it's definitely been unhealthy for the last hour. Let's check it for 1 day. I want to see when did it start becoming unhealthy. So you can see that yesterday around 3:30 p.m. is when it started becoming unhealthy. And what does that mean, that it was unhealthy? Well, we've created some service level objectives for this particular service. So here's the SLO. If I go into the SLO details page, I've created a single SLO. It's a latency-based SLO. You can create one or more SLOs per service. Let's edit this SLO and let's start at the beginning on what that even means. So the first thing I want to do is I want to select my service level indicator. It could either be availability-based, latency-based, or even a custom metrics-based. In this case, we're doing a latency-based indicator, and it's a request-based SLO. We go to the next screen. I've set my latency threshold to 2 seconds for the 95th percentile latency. So I'd like my 95th percentile latency to be 2 seconds or lower. And you can see from the historical data that it's been creeping up over time, all the way up to 8, 9, 10 seconds. No wonder it's acting unhealthy. Here I can set the compliance period for a single day, for example. I'd like 75% of the time to be within that service level objective, which is that I would like my 95th percentile to be 2 seconds or less 75% of the time. And obviously we are not meeting that. And that's why it's unhealthy. You can also set alerts that gets fired as it becomes unhealthy. We can also get into further metrics. Which particular deployment is causing that? So in this case, I can break this down by location. It could be a single region or a single cluster or a specific instance of that cluster. I can go very granular into figuring out exactly what's causing that problem and then go and mitigate that problem. In this case, we're just running it into a single prod cluster in one pod, but let's say this application was running on multiple clusters in multiple regions. You can start to now drill this down and troubleshoot it. Speaking of security postures, if I go to connected services, for the checkout service, I can see both requests coming in and out of that service. So I can see who is talking to that service and who does that service talk to. So I'm in the inbound request page and I can see that I'm only receiving requests from the front end service. And I can also see the security posture, which is this green lock representing that this traffic is encrypted using MTLS. Similarly, I can go to the outbound and you can see a ton of other services that it talks to. And every single one of these services, I can see the port as well as the security posture where it's all encrypted. So hopefully this gave you an idea of how we can take a monolithic virtual machine, use Migrate for Anthos to convert it into a container and run it onto Kubernetes. And then over time, as we refactor this application into microservices, we can use Anthos Service Mesh to implement some of the Google SRE best practices into your platform.
All right, so let's recap real quick. So the first thing, we identified the VM running in virtual machine that's on the left-hand side. We took a WebLogic server. The first thing we want to do is migrate it to Anthos, so uplift the platform. We did that using Migrate for Anthos. We made the VM much more lightweight by excluding some of those files and folders that Harish talked about before. And then we deployed that to a staging cluster inside of GKE. Now we can start using benefits of ASM and such. Now, sometime later, over time, we've turned that service into a number of microservices. And at that point, we can really start to get the value of Anthos service mesh. We can look at the topology, we can get the metrics, we can start setting SLOs per service, and we can really start to incorporate some of those SRE best practices. So hopefully that gives you an idea of a life cycle of an application going from a virtual machine inside VMware all the way to microservices inside of Anthos. Back to you, Harish.
Thanks, Ameer. I know we covered a lot of stuff today. So as next steps, I'm going to leave you with 2 links, which is going to help you. First is bit.ly java-anthos, where you can learn more about how you could use Anthos for your Java modernization journey. And then link 2 is bit.ly java-anthos-blog, where we're talking about the steps that we covered today on how you can go through methodically to achieve the modernization journey, as well as you will find a link for a free trial to get started on your modernization journey with Anthos. Thank you all for joining today.